Hi, we are going to see about depth first search in graphs, which is one of the traversal algorithms. The name is depth first search. So this graph is we're gonna take for example to do the problem solving, and we're gonna start the traversal from node E, which is this node, and the graph is containing 8 nodes totally. So we are gonna use a data structure called stack, and our output will be put up in a different array here. So this is stack, and you see the stack grows like this. So this bottom of the stack, this is the bottom of the stack, and the top grows in this way. So bottom of the stack like this, and the stack is one sided. So you can it is following a LIFO principle. Stack follows LIFO, last in first out, or first in last out. So last in first out, so this one sided. So stack people nodes will go inside and come out in the same side. It's not like queue has 2 pointers, one is front and rear. Now stack has only one pointer, which is top pointer. Top points to topmost elements. Push and pop operation will happen in one side only, where the top points to. So topmost element will be removed in pop operation. The new element will be put over the top element in push operation. So stack is used by depth first search. So it's application of stack, you can say. So we'll do this example. Here we have a node E. So node E is put up in the output initially. So we will traverse through the graph starting from node E. So we have to objective is to visit all the nodes. We have to visit all the nodes of graph finally. That's objective. So E is the node we started. We are searching from E, which are all nodes directly connected, or we say adjacent nodes of E. Adjacent nodes of E are, we can just say B and sorry, adjacent nodes is B and G, or you can put G and B, no problem. That is not a sequence, doesn't matter. So you can put B first, and you can put a G here. Okay. So E is connected directly to B, and E is directly connected to G. It is put up on the stack. Now, where we have to start the search again from? This is the top of the stack. Top of the stack is pointed to G. So you have to remove that and put the G here. You have to search from the topmost element. Now the topmost element is B. Now the topmost element is B. Now we will search from G. G is here. G is directly connected to E, which is already in the output. So we will not be like discovering new. Discovered things should be put up in stack. New nodes discovered should be put up in stack. So G is connected to A. So it is A is not in the output. That means it is not discovered and not scanned from. And A is not there in stack. So I put A in stack. Then now A is top of the stack. Then G is not connected to anything else. Now again, so we move the top to output. A comes here. I'll remove this thing. Now top is pointing to B. Now we scan from A. A is connected to B, which is already discovered. A is connected to G, which is already in the output. That means discovered and scanned. A is connected to D, so it is not at all there. So it's a newly discovered. So that's the top. So we add it in the stack. Now we remove this element D and put it in the output, and we want to start the search from D. So the top is pointing to B now. Now D we are going to scan from. D is connected to A, which is already there in the output. D is connected to F. So F is a new thing. We put F here. We put F over there. Then nothing else. It is not connected to anything else except F. So F is now the topmost element here. So we are taking F and put the F in the output thing. F is removed and put up in the outputs. So top is again pointing to B. Then F is here. We search from F. Then C is a new thing. Now C is the top. Then C is put up here. I scan from C. So H is coming. H is a new discovered. It is not there anywhere else. That means I'm adding, and I'm removing again H from the stack. Scan from H. H is connected to only C, which is already there in the output, so nothing else. So again, so this is top of the stack. Top of the stack, I'm putting in B. I'm sorry, put the B in the outputs. So I'll scan from B. If we scan from B, B is connected to E, which is there in the output. Then B A, which is there in the outputs. Then F, which is there in the outputs. That means no more newly discovered, and the stack is empty. So that's the stoppage criteria. Stack is empty, so we are stopping. Okay, so this is the output of the DFS, depth first search. If you analyze, you will see one thing. So we start the scan from E. E is here. Then we go to G. Then we go to A. We go to D. Then we go to F. Then C. Then H. So we are taking the deepest route. We're following this one. Since say B is directly connected to B, but we are coming to B after the last point only. So when the E take this route of G, it is going into the depth, in the G depth. So B, G, then A, then D, then F, then C, then H, then the depth stops here. Deeper, there is no more nodes which are deeper than H. Then I'm coming back. So this F, and I'm coming back here. So B will be encountered. So B is finally put up. So that is what. So here it takes the depth routes, then it will trace back. So it's kind of a backtracking also will be happening. So depth first search algorithm uses stack, which is a LIFO principle, and this is how it goes. Thank you.